Okay guys, I have a repair project to do. His sander to fix. It had a lot of vibration. It's an old Craftsman, very old belt sander. Very heavy, very solid, and he likes it a lot. It's a commercial brand. He was getting a lot of vibration. A lot of noise, a lot of vibration. And so when I took this here cover off here, where the dust extractor is at, I discovered that this here squirrel cage was caught up in here, tight in here. And so as the motor was turning all the time, it would cause that there to move oblong, like a off-center weight, counterweight. So I have a little machining project I'm going to do here. I'm going to try to fix this for him. He suggested that I could fix this for him this way, and I'll show you what I'm going to do here. Okay, so the first thing I want to do is, I can't get to this here screw. The screw is very tight that holds onto the shaft here, and I can't hold the motor shaft to get that screw loosened because there's nothing to hold it with. The squirrel cage actually broke off its own flange onto a bearing here that fits over the motor shaft, and then everything gets bolted down. So I have to take this out first, which just comes off its own flange here. It just pulls up out of here. Okay, as you can see here, this is what's broken off. That comes right off like that. It broke right off its flange, and the rest of it is inside here. And I have a hard time getting this here screw off the shaft. It's very difficult. So what I'm going to have to do is I take this here front housing off, but this here flange has a broken piece all the way around here that keeps this housing from coming up all the way. So I'll take this here housing, screws off of here. As you can see, part of that there flange that broke off on there is keeping the housing from coming up. I can't get the housing up. I need to get this housing off in order to be able to hold that shaft so I can twist the screw. I have two alternatives. I could either get my Dremel and try to cut around the bottom here to get that there broken flange off. If that doesn't work, then I'll have to cut the plastic itself a little bit to get that off past here. Okay, I'm going to take my little Dremel here, and I'm going to try to grind away that there shafting here. I'll see if I can get you guys close up here. You might be able to see the broken part of the shaft right here. Right here, the flange being broken that I'm grinding off right around, all the way around the perimeter there. And if you can see that or not, right on the edge here though, there's a lip about maybe 32nd of an inch all the way around, and that's what I'm grinding off with my Dremel right now. There it is. Okay. Okay, as you can see, it originally went on here like this and was one piece like that. So what I'm going to do is I'm going to try to take this off, and I'm going to try to make a flange that will rivet onto here and then fit back over the shaft. But first of all, I have to see if I can get this off now. But now I got the cover off, I can hold this now and be able to twist this, hopefully. Okay, let's see what we can do here. Don't want to damage the shaft. That's a left-handed screw. That's a left-handed screw. Alright. There, that's it. That's the part that was part of this right there. So I can make a new piece to fit inside here, possibly, using this dimensions here. Alright, let's see how that works. Okay, this flange is up right here a little bit here, so I want to just take a little bit of a, take my time here and try to get this back in, down a little bit. Form it back down, even. And keep on working that. So what I can do now is I can just set this on here, my dial indicator, and just get myself a little bit of a reference. Okay, here's a little setup I have going on right now. I have a V-block against my dial indicator base here, so that I can turn this and keep it concentric in the V-block here. Then I also have my dial indicator here, and all I'm really checking for here is I'm just checking to see how much of a run out I have from as I go around the diameter here, because this is where the flange is going to be put at. When I make the new flange, I'm going to be coming out to this diameter. So I'm just checking to see how much run out there really is. And it seems to be about a 5/1000. There's the high point. So I come back around again. I have a mark on my thing here where the low point is at. So it seems to be about going from 0 to 5/1000. So I'll hit the high, where the high point's at 5/1000. I'll try to tap that down a little bit more. So I'll turn slowly now until I get to that 5/1000. About right there, I'll make a mark here. And now I'm going to tap that there a little bit. Come back around again. And it's coming back down to 0 again. Here, so it appears to be only one spot at a very low spot, but the rest of it seems to be, see that's ramping. So it seems to be holding at that point right there. So it seems like it's not any high spots as much as it's just that one little low spot there that's causing it. So I think that's not too bad. I think I should be able to work that in. Okay, the next thing I want to do is I want to take some measurements here across different places here and see how much it's off. Right now, 950 right there. Come across 180 degrees from there. 950. Come 90 from there. 949. 180 from there. 940. It's staying pretty well even on the rim. So I think that's going to be okay to work with. I should be okay. That's pretty well flat enough now for what I need to put a flange on there to rivet a new piece onto there. It looks like it's pretty well flat now to work with. Okay, now this is my plans for doing this project here. Unless I come up with something that does not work or something, but this is going to be my original plan here. Number one, I'm going to machine a shaft fixturing that I can use to, when I go to machine the actual flange bushing, I'll have something to fit onto, plus that shaft fixturing is going to be used later on down here in step 6. Number 2, I'll machine the actual workpiece itself, the flange bushing. Number 3, I'll drill the rivet holes into the fan, which is this workpiece here. I'll drill probably 4 rivet holes in there. Number 4, I will set up fan in 4-jaw chuck, and I will indicate it in. So indicate it into its 0 reading. And then I'll use the shaft fixturing in tailstock to align flange bushing, and then glue and press in position onto fan. And then I remove from lathe drill, then flange bushing, uses fan hole as template, and rivet both together, and then install everything back on the belt sander. So mainly what I'm going to do is I'm going to make a shaft fixturing that will allow me to eventually line up the flange bushing that I make on my tailstock, and then press everything, slide everything into the actual fan when the fan itself is sitting in a 4-jaw chuck in the lathe, already indicated in and zeroed in. That would help line everything together as one concentric unit with each other. And then I'll temporarily put a little glue in the bottom, press it in. Once it dries, I'll turn it over, and then I'll drill the holes and then rivet, and then that should be the project done. So right now I'll do is I will go to my drafting board now and draw up the flange bushing that's going to fit inside here now.